Rong is a software engineer and a committer on the Apache Pinot project. He's also leading the development of the new MultiStage query engine in Pinot. Now, that may sound like deep database internals, and are we really going to go there? Well, number one, yes. And number two, it actually unlocks some important new features and really expands Pinot's ability to be kind of ANSI SQL compliant going into the future. Really worth looking into, digging into. We had a fun conversation. So check it out on this episode of the Real-Time Analytics Podcast. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I'm joined today by Rong. Rong is a software engineer who works at StarTree and is also a member of the Apache Pinot project. Rong, welcome to the show.
Thank you, Tim.
You got it. I want to talk to you today about the a thing going on in the Pinot world right now, which is the so-called V2 query engine or multi-stage query engine. We've had blog posts about it, and there's been a lot of discussion. Before we do that, how did you come to be working on Pinot and in data infrastructure? I mean, tell us a little bit of your story of how you got here.
Oh, yeah, absolutely. So I think I started to get into real-time analytics or streaming analytics when I was back working at Uber, when we were trying to basically process gazillions of data on real-time fashion so that you can actually power some of the analytics, machine learning pipelines, and everything else that basically makes decisions in real time for trips, for like deliveries, etc., Uber. And at the time, I think several of these like real-time analytics use softwares that were actually being evaluated. And then Apache Pinot was actually one of the selections that we did in Uber to power our real-time analytics, dashboards, etc.,
What year would that have been?
That should probably be 2015 or 16. That was
okay. You were early adopters. Yes. Okay. So Pinot is embryonic at this point.
Yeah. I actually have the opportunity to get to know the both sides, from the ingestions, from the streaming processing. I was actually working with Apache Flink at the time, and then also the destination of those streaming processing results, which is Apache Pinot at the time. So again, I've been mainly working on developer composabilities or semantics, basically make developers' life easier to basically give them a very reasonable and very useful libraries or tools for them to compose their programs or applications. SQL happens to be one of the most important thing in the analytics world, and also to some extent some of the machine learning world as well. The idea behind the scene for Apache Flink's SQL or Apache Pinot SQL is basically we wanted to get them as much aligned with the SQL standard as possible, so that general developer or users, data analytics, data engineers, etc., they can actually use their common knowledge that they've been learning since 1970s to be able to compose their programs, applications in the way that they think that it would always work the same way as it has been since the last probably 50, 60 years. Mm-hmm. Now, that's what the challenge for most of the analytics at the time, back in the 2017s and 18s, etc., that has a limitation of, right? So there is obviously a trade-off between speed versus complexity of the programs that you can express in terms of the SQL. At the time, Pinot does not support really complex multi-stage or multi-pipeline or multi-pipeline breaker executions of SQLs. For example, if you wanted to do complex match-recognized event analysis, you wanted to do joins and group bys, you wanted to do a lot of these other things. But at the time, it was actually okay because not a lot of these analytics requirements are actually trying to deal with those type of complex use cases.
Yeah, I mean, traditionally, like in a traditional data warehouse, I guess technically there are joins happening between dimensions and facts, but your the ETL process, and I know I'm talking about ancient history here, but that sort of did the denormalizing for you, and so joins aren't the thing that come to mind, like, hey, I have this fast analytics database. I sure hope it does joins. Like you don't say that first. Yeah, but I want to actually dig into something you said. You said complex multi-stage queries, and I don't know if you're talking about the execution model of the query or the structure of the query itself. So when you say multi-stage query, that makes me think of like nested selects or something, nested queries. Is that an execution implementation detail you're talking about? Tell me what you mean.
That's actually a good question, right? So I think when I express in multi-stage, it's more like an executional model rather than a logical SQL structure model. What it means to probably some of the users of SQL is like I wrote nested queries with statements, materialized view queries, etc., etc. We have some subqueries, etc. That's sort of like a SQL semantic level multi-stage, right? So you have several queries that looks like you want to execute it first. But then the most of the modern SQL planners and optimizers will be able to figure out some of the SQLs that you wrote it out as a nested query or kind of like a join can be really flattened into a single stage query, right? So that's where the planner and optimizer is really, really good at. Now, contrary to that, for example, if you wanted to do some let's use a really simple example, right? You wanted to do a group by and then an order by, and then you do some kind of like post-processing after you're ordering, right? So a lot of the time, if you wanted to do a global order by or a global group by, and then your data are not correctly partitioned for example, with your group key, then you can't really do all of your work on a single machine. And that's what I meant by operational multi-stage. It's kind of like you have to complete a pipeline or complete a stage first. And then you need to introduce a pipeline breaker for the signaling mechanisms in many of the modern database systems. Okay, my stage is complete. The next stage can carry on, right? There are obviously a lot of the executional models in the modern data stack that actually does it a little bit differently from one or another. For example, you can have like the next stage to be completely coordinated to be non-scheduled. The other way around is you can schedule the next stage, but you are basically awaiting for the data to come in, right? So there's kind of like a trade-off of pros and cons of that. It's more like latency versus efficiency in terms of like a computational resource usage. So when I say multi-stage here, is specifically referring to the runtime multi-stage.
Gotcha. The execution phase. So you've got parsing and planning, optimization, and execution. It's an execution, and so that was a good. I want to key on that thing where you said you have a group by and an order by, and generally the order by is going to be executed last, but the group by is going to come before that. And if you're grouping by something that is orthogonal to the way you've partitioned the data, then you got a problem. And that's so when in Pinot, talking about Pinot, when would you? What are the circumstances where you'd be grouping by something that where the partitioning was helping you?
Yeah. So, for example, if let's use a very simple dimensionality analysis, right? So, let's say you wanted to slice and dice your analytics results by user UID, right? For example, you have a bunch of users. You have a bunch of, let's say, transactional logs from your like iOS app or Android app or something that you recorded what the users has been doing on the app. Now, let's say I wanted to know how many times it clicks a specific advertisement, right? So that I wanted to slice and dice by user UID, or I can slice and dice by the user persona, etc., etc. Now, if the data is already pre-partitioned by the user UID, like let's say your ingestion streaming system is actually partitioned the data by user UID, then your data that ingested into, let's say, some OLAP systems or like transactional databases,
right? Like it's in a Kafka topic and user ID is the key.
Yeah.
So
Then
my
naturally partitioned by the user UID.
My segments are going to have all the same user IDs to some approximation. Okay.
Exactly. Now, then you can basically do your aggregations in a really, really efficient fashion because you know that all of the data you're going to group by is going to be on that location. Then this is no longer a multi-stage execution model, right? So you can do everything on a single stage. But now let's talk about that example in a different way, right? Let's say you don't want it to group by the user UID, but you want it to group by the user persona, right? For example, you want to group by, like this user is between 20 to 38. I don't know if that data is collectible or if that's even possible, right? As you said, example.
Maybe it's illegal. Somehow we've come by some idea.
Right.
You created a profile, you put your name in, your age, you volunteered, and
exactly.
Somehow,
So basically, but this is
for it on the dark web. We're not sure where it came from, but there it is.
Yeah. But let's say this is something that you cannot group by, right? Or sorry, you cannot be pre-partitioned by that. Then you cannot assume that all of the data that you're trying to make in terms of that group is actually part of the single server. Then you need to carry on all of these intermediate results so that you can actually do another stage to basically shuffle the data around, making sure that all of the data that is within the same persona goes to a single server, and then that server can basically produce a final group by result. So that's what we talk about. Like you need to have a pipeline breaker. You need to make sure that the data are co-located. Then you can finalize your results in next stage, not the first.
Got it. So and that is the innovation. That's the fundamental innovation of the V2 or the multi-stage engine is that it will now do that.
The idea for the Pinot's V2 engine is sort of like a pipeline executional model, but it mostly trades performance efficiency with latency throughput benefits. So because for most of the analytics use cases that we are targeting right now is users wants the data to be like the result to be there as soon as possible. It needs to look at the real-time data as close to current as possible. Thus, like with that goal in mind, sacrificing a little bit of the performance efficiency when you're utilizing the computational hardware is actually the benefit that we are going to target against. So this is what the V2 engine is targeting against. It is actually geared towards optimizing the latency, the throughput for the system, rather than gearing towards the computational resource usage efficiency.
Okay, because a join and enabling joins is kind of the short-term goal, right? That's
So
that's the subheading on the blog post, and that hypothetically would have been possible in the previous query engine. It's just that between broker and servers, there would have been a lot of data moved, and brokers weren't really set up for that. It just execution times would have been, our claim to being a real-time database would have been a little thin.
Right. So that's actually really interesting. So now that we're talking about Pinot, right? So technically Pinot's previous execution model is actually a multi-stage model, but it's actually a two-stage model. So it's
fair enough.
Definitive two-stage model, right? So
yes,
you have the broker to basically do the second stage, right? For example, when you're actually trying to do group by, right? And then you don't know all of the data are actually writing correctly on each one of the servers. Then your broker basically becomes a second stage. And because the broker is a single node, it guarantees to have the global view of everything that is actually going to be returned by the server, and then it's actually doing the work for the second stage.
And very briefly, if you don't know Pinot, there's 1 to n brokers. Client request comes in, the query is submitted to the broker, and then that broker is responsible for completing the execution of that query by scattering the query to servers, which is where the data is stored and where most of the work is done, and then gathering it back. So that's that second stage. So if you don't know Pinot, broker, server, those words that we're talking about. We're sorry, server, I know is very ambiguous, but in this case, it means that particular node where the data lives, the true heroes of the cluster. So go on. Yeah, it was two-stage, very fair point. Yep. But now do servers get to decide to build an arbitrary number of stages? Like how's it work?
Yeah, so technically speaking, you can actually model join or all the other complex executions in a two-stage model with kind of like a two-stage chaining two-stage, right? For example, like if you wanted to do a fact dim join, right? You have a fact table, you want a dimension table, you want to enrich that fact table with some kind of a dimension, you find the user UID, like the example.
Seems like one might do that, yeah.
Yeah, now you do pre-processing on the dim table, getting all of the information that you get from the dim table. Let's say you wanted to do some kind of group by or something like that. And then what you actually do after that point is you issue this first two-stage executional query, and then you bring the result back, and then you ship the result along with your second stage join to the fact table, saying that, hey, this is a dim table. Go enrich that with the result that you got from the first stage.
Okay. Dim table filtered, presumably, we would
correct.
want.
Yeah. For example, like this dim table is already materialized. We already got this from the first execution of the two-stage execution. Now, this is your second execution of the two-stage execution. Here is the result of the first time that you got the dim table. Now, let's go enrich your data. And this is what the lookup joins, insert queries, and all of these nice optimizations on the Pinot's existing engine is actually doing right now. In most of the cases, it's executing quite well because on the fact dim join use cases, your dim table is relatively small compared to your fact table. But in fact, the magnitude is smaller, right?
And you're talking about stuff that already works pre-V2, right? Yeah.
Working, right. Yeah. Now, but what it gets challenging is when if you look at the multiple execution of the two-stage engine model, your broker becomes your definitive bottleneck, right? It's a single point of failure. Every time you're trying to do something with the two-stage, your broker is basically a single machine that is holding the entire clusters of data after your pre-processing. For example, like you have some type of filter and slice and dice. Obviously, that is going to be really, really efficient on the server side. But once you bring it into the broker, that is always one machine. Now, the multi-stage engine is designed specifically to tackle this type of use cases, right? For example, if you want to do a fact join, you have two fact tables. Now, that becomes a problem because now you almost guaranteed to not be able to fit all of your data into the broker's memory.
Yes, because they're both big.
Exactly. This is where you need a second stage. Well, you can so basically, so let me dial back a little bit, right? So originally, the goal for the multi-stage engine is tackle fact join. Mm-hmm. You have the tables. These tables cannot fit into a single service memory, but you know that your join is based on high cardinality key. Now, what you can do here is, instead of having broker to be doing the exact reduce in a single machine fashion, you can chain a whole bunch of servers, partitioned by a whole bunch. You can potentially use all of your servers on a single cluster. And then each server is responsible for a specific subset of the join key. And then you ship the data between your fact table on the left and fact table on the right to that specific table. And then that table is to that server, and that server is only responsible for joining a subset of the keys. And then you can do everything in parallel because you have the entire cluster of the computational resource you can use.
Because you have a distributed database, and so it actually uses it as a distributed database. And again, this is the case of a fact join with a high cardinality key, meaning, yes, you're filtering the left-hand fact table, but you're getting an awful lot of records back because it's a high cardinality key. And that's just the nature of the join. Okay.
Correct. Now, that's the initial goal of the multi-stage engine. But when we actually design the multi-stage engine to deal with these type of use cases, we realize that if you can chain another stage, why not just chain arbitrary many stages afterwards, right? So you can actually create a generic purposes, fully SQL compliance engine behind the scene. All you need to do is basically creating a relatively reasonable pipeline break multi-stage plan, and then each stage within this plan can be executed in a kind of like context unaware fashion, right? So if you're looking at typical fact join use cases, your join state does not need to know how these results are. For example, the left table's join key and the right table's join key are coming to this intermediate stage. All it needs to know is someone is already doing the work for pre-filtering, pre-aggregating some of the results on the left table and the right table. All I need to do is, I know there's some data from the left and some data from the right, and I'm going to join them together. This is my stage. Mm-hmm. And later on, if we want to chain another, say, complex event analysis operator, for example, I wanted to look at a sequential train of kind of like a website section or application sections within your phone. That session starts with a login, and then chain with a whole bunch of kind of like website clicks or kind of like an advertisement clicks or something like that, and then eventually ending in the user doing something, right? So this type of complex event analysis is also another stage that you need to do. Let's say that's the thing that you're after the join, right? So it does not need to know how the join is being happening. All it needs to know is this is what I need to do, and this is the input from the previous stage that I expected to happen, and then the entire thing gets chained together.
And so it used to be that a broker would give those instructions to a server, and now basically servers can instruct each other, can say, well, this
exactly, yeah,
there's a chunk of things. Yeah.
It's kind of like broker may or may not be able to deal with complex event analysis depending on how the system is being constructed. Because obviously the two-stage chaining together, kind of like one two-stage, the second two-stage, third two-stage execution model have its limitations. But a generic multi-stage executional engine definitely has much less limitation in terms of how.
Yes, and that's a pathway to full ANSI SQL support. Where does the decision about the stages get made? Is that still in the broker?
Yes. The broker would have kind of like, so basically here is how kind of like a user's journey come to life in a multi-stage engine, right? Technically, it's more on the standardized SQL executional model, right? So the SQL query comes in, an executional planner basically plans the SQL and decided that what exactly is the relational algebra behind the scene. That's where we constructed the relational plan, the relational plan tree that basically tells like, it starts with a global reduce. Like, for example, I have a limit 10, right? So at the very end, I only need 10 results back. And then I have say I have a group by, it's grouping by some key. And then this group by is feeding in by another projection operator, a projection, right? So project basically select out some of the fields or some of the columns, doing some like scalar level like functions, and then the result is getting feeding to the group by. And then afterwards, that's going to be the join feeding the data into the projection node. Like after you join two tables, for example, I want to add the column on the left table and the column on the right table together. That's your project. But then the join node is actually feeding data into the project node. And then from the join node, you have your left table computation, right table computation, etc., etc. So this is how, as far as I know, most of the SQL engine is actually doing a very composed executional model. I mean, the SQL that the user provide into an executional tree. Now, this is where I think many databases doing slightly differently from each other is, in Pinot specifically, the multi-stage engine in this case, at this stage, would ingest more of the physical information of the tables into the plan. So basically telling you like once you have the logical plan or the plan that we just talked about coming directly from the SQL that the user provide, it needs to know, hey, where is this left table? Where is this right table?
Yeah.
Is it distributed? How is it distributed? And where can I select the most optimal set of servers that reduce the amount of network shuffling that is required?
Themselves have the largest subset of the segments that I actually need. Okay.
Yeah, exactly. Sense. Yeah, so
servers now need that metadata. That used to be just a thing brokers needed, but now servers need that so they can make decisions about where the next stage is going to be.
Interestingly, the broker needs to know the global view of the servers. That's where it makes decisions on which server to choose.
Yeah, because it's picked the stages, and so it's kind of got that plan before any of this starts. Got it. Okay. Yeah, we already covered that.
So that's one of the advantages of Pinot is because it understands all of the data underneath. It understands all of the computational resources available to it, and then the broker basically made a decision to generate a static executional plan with a whole bunch of stages that can be pipelined together.
Yeah. Well, key point. That's key point just about Pinot, not even the multi-stage thing, but Pinot maintains its own storage. Like I've had people ask me, so what's the storage? I'm like, well, there are file APIs and you put bytes on a disk, right? and you have to have that. You have to have that metadata to be able to clock the latencies we do. It's not like everybody else is just lazy and we just wrote a real good database that's real fast. That's the key, is that where the bytes are.
Exactly. Yeah. So to summarize, is basically the multi-stage engine in Pinot is having a relatively standardized SQL planners, logical planners, etc., to basically convert the user SQL into a standardized version of the logical plan, where it tells you how the SQL is being executed. It doesn't tell you what is being executed upon. And from that point forward, Pinot makes the decision to ingest those informations at the plan time from the broker, which has a global view of all of the information of this entire cluster. Well, it's loosely, it knows all of the information within the tenant that the broker actually being responsible for. But yes, that's the idea. It has a global view of everything. And then it makes the decisions on how the plan is being chopped up into stages or pipelines, and then how those pipelines are being executed. There are a lot of difference comparing to the rest of like some of the analytic worlds, like databases, right? So some of the databases decided to make gradual decisions on where the servers are, how the things are being planned. For example, like some of the databases I know that, for example, if you're doing a join query, it would actually execute data in a very, very small subset of data, collect some executional stats, and realize that how expensive or cheap each one of these operators are. And then make the decisions on whether I wanted to broadcast the right table to the left table, or I wanted to do the global distributed shuffle hash join.
Adaptive, kind of.
Exactly, yeah. Now, all of these use cases have their pros and cons. It may trade a little bit of computational resources in advance to gain a relatively more real-time decision-making efficient global plan at the very end. Or, for example, like you can always do something like a map reduce model, right? So until your map stage is finished, your reduce stage is not actually occupying any computational resources. In this specific case, is the join stage would not be executed, would not be dispatched to any of the computational servers until your left stage and the right stage is complete. Now, they all have pros and cons. It is just a matter that Pinot's MultiStage Engine is decided to go with single decision, single point of planning, right? Rather than having
the broker,
global coordination. Yes.
I had one more question. Mm-hmm. You said something that I now have two more questions. Briefly, though, you said MapReduce, and it's occurred to me before that when we used to talk about MapReduce, we never mentioned Shuffle, right? It was Map, Shuffle, Reduce, the silent partner that really took all the time that we just didn't like to talk about. I mean, that's kind of still here. So the shipping of data between servers, it seems like optimizing that's where the attention is going to be going forward as we're squeezing performance out of the engine. Is that intuition right? Is that the thing?
Yeah, absolutely. Right. So the more and more we get into the development phase of the MultiStage Engine, we realize that, as you said, right, so the shuffle stage is definitely one of the main bottlenecks that the MultiStage Engine needs to deal with. It is relatively silent if you look at, because there's no map stage or reduce stage, right? So every stage is doing its own work. It's accepting data from a previous stage, doing some work, and then sending the data to the next stage. This is how it actually becomes simple to manage, relatively inexpensive to execute. And but it basically push all of this responsibility to the guy who actually, to the software that basically makes sure that the data are actually shuffling correctly around in between stages. So this is where the streaming component comes into play. So we designed a mailbox mechanism in the MultiStage Engine that basically handles these type of data shuffling. Obviously, it is going to be relatively optimized using the relatively low latency libraries behind the scene. But a more important part of it is how do you make the shuffle unnecessary in the first place? And that's where collocated joins and dynamic filtering joins are actually coming into play. This is one of the things that we designed or presented in the roadmap for 2023 as well. Yeah,
that's the best kind of shuffle is the shuffle you don't do. But it's just funny how every system I look at like this, it's like shuffle is like popping up in the corner and winking at you. It's still kind of there. So wrapping up, your unofficial recommendation, when can we use this? I mean, it's in Pinot 0.12 in a pre-production form. Time to play with it. What should people's expectations be around that?
That's a good question. So we are actually doing days and nights and trying to stabilize the system and making sure that it is production stability, I would say beta stability, ready for 0.13 release. This is what we're gearing towards. A whole lot of community members from Uber, LinkedIn, Stripe, and all of these other companies are actually trying to chime in to help us to make sure that this happens before the 0.13 release. This is where I think we can finally try this on production and collect more feedbacks on a much, much larger data set. So when we announced it last year around August and September, it is basically, hey, you can play this around with your local MacBook or something like that. Now this is where we are targeting for we were targeting for the 0.12 release, and for the 0.13 release, we're targeting you can actually play this around with the production cluster. And the next stage would be a general availability and production readiness, which will come after the 0.13 release.
My guest today has been Rong. Rong, thanks for being a part of the Real-Time Analytics podcast.
All right, thank you so much, Tim.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.